Hey guys, welcome to another video for pre-calculus. In this video, I'm going to be working out some of the problems from 5.4, multiple angle and product sum identities. So I want to dive into some of the work in the book so that you can see how these identities are used and then the various problems that you have in the text. So let's go ahead and dive in. I'm going to work out some odd problems. So number one states it's given you that cosine theta equals 3 over 5. And it wants me to find the values. Let me just put this smaller. It wants me to find the values for sine 2 theta, cosine 2 theta, and tangent 2 theta. Okay, so this is my these are some double angle formulas that I'll be working out. So I'll be working with the problems, the formulas that are down at the bottom left there. I'm going to square it there. And so my given value is cosine theta 3 over 5, and it wants me to find the values for these in the given interval, which is 270 to 360. So if I'm looking at my unit circle, I'm looking at the values that are here. Let me do it in red. So these are these values here, from 270 to 360, okay? So now, one of the things that I want to do is as I look at these problems, I want to kind of look back on my original trigonometric value for cosine. And if you recall, cosine theta equals your x over your r, or your hypotenuse. So in other words, your 3 value is the x, so this is 3, and then it's telling you that your r value is 5. So I want to find my y, okay? And so of course in this case I'll just use my Pythagorean theorem, and with Pythagorean theorem, just to quickly work this out here. It's 5 squared minus 3 squared. Now recall, this is a negative sign because I am working within this interval right here. And if I'm working within that interval, that means that my y values are all going to be negative. So I'm just going to put a negative sign right there. Okay, so that's 25 minus 9. That's square root of 16. That is a negative 4. So this is a negative 4. Okay, so that's how I found my y. This is going to be helpful because, as you can see here, my first term is sine 2 theta. So if you recall, sine theta in my original trig functions, or trig values, that is y over r. So now I know my y. My y is negative 4, and of course my r is 5. So here's the value for sine, and I have the value for cosine. And the formula, the double angle formula for sine 2 theta is 2 times sine theta times cosine theta. So that's 2 times, and then my sine value is negative 4 over 5 times 3 over 5. Okay, and then just do the arithmetic with that. So that's 2 times negative 4 times 3, that's negative 8, that's negative 24, all over 25. And there it is. There's my value. There is my value for sine 2 theta. So the next thing I want to find is cosine 2 theta. Let me erase this part here. Don't really need that. So I want to find cosine 2 theta, and the double angle formula for cosine 2 theta is cosine. Actually, now cosine 2 theta, you'll notice that there's actually 3 formulas that I can use. So I can use any one of those 3 there. Let's use the first one. Why not? Cosine theta minus sine squared theta. So cosine squared is 3 over 5 squared minus sine is negative 4 over 5 squared. So that's going to be 9 over 25, and that's a minus, so that's plus 16 over 25, and that is going to give me 24 over 25. And that's the value for cosine 2 theta. And I could do any one of those three formulas and still get the same thing. So either way I would have gone there, I would have been fine. So the next thing I want to find is tangent to theta. So as I look at tangent to theta, I want to get that value. What is the value for tangent theta? Recall that my function, my trig function, is y over x, which is the sine theta over cosine. So my y in this case is negative 4 over 3. So this is the value for tangent as I look into the value of tangent to theta. So let me get rid of my work here that I did earlier, so I can have some space. So let's work this out. So the formula for tangent to theta is 2 tangent theta over 1 minus tangent squared theta. So in the numerator, it's going to be 2 times negative 4 over 3 divided by 1 minus negative 4 over 3 squared. All right, so let me work out the numerator first. So this is going to be negative 8 over 3 divided by this. So let me work that out down here. So 1 minus negative squared. So that's going to be 1 plus, or no, sorry. It's going to be 1 minus 16 over 9. And that 1 I can change to something that I can work with. It'll be a little easier to work with. And let's change that to 9 over 9. So that'll be over 9, negative 7 over 9. So negative 7 over 9. All right, so clearing up my space here. So I'm left with negative 8 over 3 over negative 7 over 9. So negative 8 over 3 times the reciprocal, negative 9 over 7. Can I simplify here? I can. That'll be 1, that'll be a 3, and that's it. So I'm left with negative 24. Actually, negative cancels, so it's actually a positive. I'm left with 24 over 7, and that is the value for my tangent to theta. And that's that. So that's number 1. So checking out number 3, I have a given value for cosine theta of negative 9 over 41. So the key to finding these, or at least the key to starting off right, is just go ahead and finding your sine theta and tangent theta. So if you recall cosine theta, my original trig function, the value for that is x over r. And for sine theta, it is y over r. And for tangent theta, it is y over x, or sine over cosine. So I already know my cosine, so my sine theta, my y value, I'm actually going to look at my unit circle. And I know that my interval is from 90 degrees to 180 degrees. And my x value is negative 9, right? It's negative 9. And my r value, my hypotenuse, if you will, is 41. So now I want to find the value for y. And I plug that into my Pythagorean theorem, and I get the value of 40. So now I know my value for y. So sine theta then would be 40 over 41. And then for a tangent, that would be 40 over negative 9. All right, so there we go. We have our tangents, our sines, and our cosines. And now it's just a matter of plugging them into our double angle formulas. Okay, so the first one, I want to look for sine. I'm going to use my green. So sine 2 theta, the formula for sine 2 theta is cosine is 2 sine theta times cosine theta. Okay, so that's going to be 2 times my sine theta, which is 40 over 41, times negative 9 over 41. And then if I do the math on this, I end up with 720 over 1681. So that's the value for sine 2 theta. All right, so now let me look for my cosine theta. So cosine 2 theta. Now recall that I can use any of the 3 formulas on here, but I'm just going to go ahead and pick one here. I'm going to pick a different one than I did last time, just so you can see how it works here. So cosine squared theta minus 1. So that's 2 times the value of cosine, which is negative 9 over 41, squared minus 1. So simplified, that comes out to 81 positive, 1681 minus 1. And that one, okay, well, let's see here. That's going to equal 162 over 1681. And since I have 1681 as a denominator, I'm going to pick a number that will give me the same denominator, and that will give me a value of negative 1519 over 1681. And that's the value for cosine 2 theta over 1681. All right, so let's clean up our board here. And now let's go to tangent. We're going to do that in gold color. So tangent 2 theta, and the formula for that would be 2 times tangent theta divided by 1 minus tangent squared theta. So we have our value for tangent, so let's put that in. 2 times negative 40 over 9 over 1 minus negative 40 over 9 squared. Okay, so that's going to, let's see, let's start to work this out. I'm going to end up with negative 80 over 9 divided by 1 minus 1600 over 81. Okay, so simplifying that. So for my 1, I'm going to pick a number that 81 over 81. That will give me 80 over 9 divided by negative 1519 over 81. So I'm going to multiply my numerator by the reciprocal of the denominator. That will give me 81 over 1519, 9. And then this simplified will give me, and so these are both negative, so they'll be positive. This will give me 720 over 1519. Okay, so that's 720 over 1519. And those are my values for all 3 of my double angle formulas. And that's number 3. Let's move on to, let's try 5. Or no, actually, let's go ahead and jump over to another set of problems. Let's go to number 9.